know. It says here, using a calculator or otherwise, all right, calculate the exact value of, and I could write it out just for us. We have 3.6 plus the square root of 51.84, and this is in a bracket, and then we have divide by 3.75. All right, so this is what we have looking at. You want to deal with the matters inside the bracket, right, as best as possible and as early as possible. So on your calculator, you could put all of this on your calculator right now. You could put 3.6 plus square root of 51.84. You could put that on your calculator right now, right, if you want. Or you could find the square root and write it. But no problem if you want to put all of that on your calculator. 3.1 plus, open the square root sign and put 51.84 underneath that. Make sure that you're not making any error. Definitely, this will come to 10.8. All right. And then 10.8, and then you want to divide this by 3.75. So you divide that by 3.75, and you're getting 2.88. All right. As you work, if you wanna send in your answer, it's best to do it on YouTube. I won't be able to look in the chat here, but I would have my phone here looking. All right. So I'm on YouTube looking, but I won't be able to go to the chat here. All right. I can, but I won't be able to do it. All right. So we're looking at 2.88. If you get 2.88, definitely you know that you got your solid 2 marks here. And it's very straightforward use of calculator that they're testing for right there. Testing for the use. All right. Part B. Part B says here, right? Part B says the diagram below, not drawn to scale, shows 2 jars of peanut butter of the same brand. All right, so they're of the same brand, and we're looking at them. $2.14 for this one with 150 grams in it, $6.50 for the next one with 400 grams. So we have situation A, situation B. The question says, which of the jars shown above is a better buy? This is the idea. What do we mean by better buy? When we talk about better buy, we're talking about the highest, in this context, it's 2. So it's also the higher value for $1. That's what you're checking for. You want to check for which of the 2 would I get a higher value. In other words, for my $1, which one of these will I get more grams for? So we could simply check them out. A, we could check out A by saying 150 gram. You want to divide that by your $2.14. And the situation B over here, it is 400 grams. You want to divide that by $6.50. So when you work these out, you're going to get the value for $1, right? So let us check out situation A. 150 divided by 2.14. All right, so I'm getting 70.09, so I'm getting 70.09 gram for $1 here. So my $1 here is giving me 70.09. Let me check the next one. 400 divided by 6.5. And I'm getting for this one 61.5354 grams for $1. You could see for yourself which one of these, right, is actually the better buy. What would you suggest? So based on what you're looking at, right, the better buy will be A, the smaller can, right? So when they said show all working, it's you putting up this, putting up that. And at the end of the day, we could say that, can they say peanut butter 150 gram is the better buy. You have to work it. All right. So a lot of times, if you put the dollar at the bottom, put the dollar part at the bottom, you're able to see what you get for $1. Because the dollar is going to be, because when you normally divide thing, you would have said 2.14 into itself one time, and that becomes the $1 at the bottom. And then it goes into the 150. 6.15 goes into itself one time first, then it goes into the 150 to 400. So that is how you would have seen $1 give me how many grams. I want the one that would have given me more grams. All right, so situation A is correct. All right. All right, so there it is. You're going. All right, so the C part. So the C part of this question here. All right, the C part of this question, as you could see, it says Thomas invested $1,498, right, at 6% simple interest. Remember, we did simple interest, we did compound interest. So we're talking about simple interest per annum, right? The interest in dollars earned after. So we want to calculate the interest in dollars earned after 6 months. This is the crucial part of the question right here, 6 months. This is not 1 year. So whenever you're doing these sort of stuff, like simple interest and compound interest, you're talking about a yearly basis. The formulas are dealt with in years. So what you want to do is to convert your 6 months to years to know what it is as a year. So 6 months is 6 out of 12. So this is 0.5 years. So you want to make sure that the formula that you're about to work out, you don't put 6 in it, because it's not 6 years. It's half of a year. Now, the formula for interest says interest is equal to your principal times your rate times your time, all of this over 100. All right, so you are able to see. So you could simply substitute principal 1498 times the rate, which is 6, times the time, which is 0.5, all over 100. So use your calculator to navigate. Make sure that you're making no errors. All right, so I'm getting that interest that I'm getting for that time, which is half of a year, is $44.94. All right, so, and this is for 6 months. We want to make sure that we understand the context, just for 6 months, not even a year. All right. All right, so let's continue working. Now, the question went further, and it says here, the total amount of money
recording
in the account. It's live on YouTube, so it's automatic. The total amount of money in his account after 3 years. All right. So now it's up to you. There are a number of ways to work this. I could show you 2 ways quickly. All right. You could look at your situation. The principal amount, which is the amount you're investing, P. The rate was 6. The time, this time is 3 years. What they want to know, watch this, the total amount in the account. I want you to understand that the total in the account will be, the total at the end will be the principal plus the interest. Everybody would note that. All right, the total in the account If you leave some money somewhere and you come back, the total will be what you left plus the interest that you got from it, right? So now what you wanna do is to go and find the interest for the 3 years, right? So that's one of the approach. So we could go and find the interest for 3 years using these. So the interest for the 3 years will be, I'm just saying this is one of the approach, all right? Let me write back the formula for you one more time. It is P times R times T over 100. So we're talking about 1498 times 6, if you already want to know, times 3 over 100. Make sure that you're writing, you know. All right, so we're looking at 269.64. Now this is just the interest. So therefore you could conclude that the total, yeah, would be 1498 plus 269.64. So we want to put that together to see what we're getting. All right, so you take your time, you check, making sure that there is no error. So I'm getting something like $1,767.64. So good to go. There is another approach that we could have taken, and I'm just going to show you quickly. Now, having told that we have 6 month interest, having told that you have 6 months interest, it was $44.94, I believe, right? Yes, it is. All right, so having told that you have that for 6 months. When you're dealing with simple interest, the amount you make for 1 year is the same until the entire thing done. The amount you make for 6 months, you'll make the same every 6 months. All right, because it's called simple interest. There is no fluctuation. So I could say how many 6 months I will get in 3 years, right? So if I have 3 years, I will end up having 6 times 6 months, right? 3 years, I'll have 6 months 6 times. Therefore, I could multiply this by 6, and it's gonna just give me 3 years interest right now. So if I say 44.94 times 6, I'll get the exact amount that I worked out just now, $269.64. Because when you understand that simple interest remains constant. So if you understand that this is for 6 months, it's the same thing, you'll get another 6 months. And if you have it for 10 years, every 6 months is the same amount. So I was able to convert that, understanding how many 6 months I could get out of 3 years, and then see the interest coming back. So if this is my interest for that time, then the total would have been the same, 1,498 plus 269.64. And we're still gonna end up getting that same money that we got before. 1767.64. All right, so same amount. So this is the total at the end of the time. So it's either you approach it like that or you take it like this. It does not matter. All right, we're able to see what's going on. All right, so we're getting the same amount there. Let's continue pushing. Now the question says here, how long it will take before his investment earn. So we want to look at the key words here, earn. When we talk about earn is referring to interest. Because if I'm gonna earn money on my money, they're asking me here indirectly, how long will it take before my interest reaches $449.40? How long? Well, we can approach this a number of ways. I'm just gonna probably just do it one way. You could take this, I mean, you could, all right, we could do 3 ways. Forgive me, I won't do all 3. If this is the interest I want to get, I could say interest is equal to this. I can just interpret this as my interest because that's the interest I want to attain. Then my principal was from the get-go, it's 1,498. The rate was from the get-go, it was 6%. What they're asking me to find is time. It's time they're asking me to find. How long? This refers to time. So I have all 3 things that I need to find time. What's the formula for time? Time is equal to 100 times my interest over the principal times the rate. This is going to equal to 100 times my interest, which is 449.40 over 1498 times 6. And we want to take our time and put that together. 449.4. All right, so we're looking at 44,940. And you want to divide this by 8. All right, so let's do the division now. 44,940 divided by 8,988. And I'm getting 5. Let me put 5 here. 5 years. I got 5 years. Now, I never had to do it that way, right? I could have done it 3 other ways, and I'm just going to show you one more way on this, just one, for the interest of time, right? For the interest of time, if I understand 6 months interest, 6 months was equal to 4494. If I know that for 6 months, I could divide the 6 months into this. And it's going to tell me how many 6 months I can get. And then I could convert back the 6 months to years. So I am assuming if I do that, if I do this now, I'll get 10 6 months, 10. And that's 5 years. So, or I could turn the 6 months into 1 year and say, I'm just showing you there are so many ways. I could multiply this by 2 and turn it into 1 year. And then look at this number. It looks familiar yet? See that number? So almost look like that. So I turn it into 1 year, and we're seeing $89.88 per year. Oh, so if I'm making that per year, then the number of years is going to equal to, watch this, the total that you want to attain over the entire period divided by how much you're making in 1 year. And it's going to tell you the straight answer. I think you're going to get 5 if you do that. 449.40 divided by 89.88. And it's telling you that, hey, it will take you 5 years. There are 2 other ways I could have done this. In the interest of time, allow me to move on. So if you see it like that, and this is how you interpret it, using these that you're looking at straight, that's fine. Somebody else might have seen this and said, hey, this is for 1 year, and then put the 1 year in the total amount so that it tells you how many years it would have taken since simple interest remain the same. The things that we do with simple interest, we cannot do it with compound interest. So remember, simple interest, the amount you keep getting is constant. And because of that, we're able to approach it like this. All right? All right, so let's go. So 5 years, as you could see. And that's a full question 1. 11 marks right there. Full question 1. All right, so start building your confidence. If you're feeling like these are things that you know you can work, just keep working at it. You're up for a very good grade, right? Number 2. All right, what number 2 says? Let me go back for my red pen. So number two says here, solve for x. where x is a real number. You're solving for x. These are what you would call inequations. They're not equations, right? Equations would come with equal sign. And we don't have equal sign there. We have what we call inequalities, greater than or equal to, less than, and so on. So I would say to you that the way in which we do this is the same as you approach an equation. There are two exceptions, of which if you multiply or divide by a negative number, the sign will just flip, like it will turn the other way. But until you reach there, you will do normal working and keep the sign. For example, if I have this, right? I'm going to write.
Sir, it's but when you multiply and divide by a negative number, the sign changes.
The sign flips. That's the only difference. That's the only difference, Jody. All right, so there it is. I write it up. When you're doing this, it's your responsibility to decide which side do you really want to keep your unknown on, because as you could see, you have unknown on two different sides. It does not matter which side you decide on, you'll end up with the same answer. So it's all about you and your level of comfort. It's about you, right? So let us say then I realize that I want to carry my unknowns on the right-hand side. So if I want my unknown on the right side here, it simply means then I am going to have to make sure that the numbers are on the other side, right? So it's up to us, and based on how comfortable you are. Look at what we're going to do. If I want the unknowns on the right side, then this negative x, I don't want it on the left side. All x's must be on the right for me. So I'm going to add x so that a negative and a positive x would cancel. But whatever I do to one side, I have to do it to the other side. I'm going to add x to the right side. In the same breath, we can do this. The 2 here, I'll highlight it. We don't need to have the 2 where the x's will be. It is a positive 2. So in order to get rid of a positive 2, I'm going to have to zero pair this. It's a positive 2. I'm going to take 2 from it. Whatever I do on one side, I have to do the exact thing on the other side. So I'm going to subtract 2 from the other side for balancing. And then we're going to simplify this now. Now, in simplification, that becomes a 0. That becomes a 0. So let us write what we really have left. On the left side, I'll have an 8 minus a 2 less than or equal to 5x plus x. So what I have here is 6 less than or equal to 6x. Flowing just like an equation. Do not trouble these unless you are, as we said before, multiplying or dividing by a negative. Multiplying or dividing by a negative. We haven't done that. Now, the next move is that we want to have the x alone, so we're going to divide by a positive 6, so that's fine. Divide by a positive 6, so that's fine. So 1 is less than or equal to x. Sometimes people like to read it from left to right. So be careful. Be careful. It means x is greater than or equal to 1. So if you look at it, x is, if you read from this side going across like that, x is greater than or equal to 1. So if you want to spin it around, you have to do that. But be careful, do not make the mistake. This is perfect as it is right there. So interpret it and understand what you have. So you would have gotten all of 3 marks to execute that. A lot of marks to execute that. All right. Now, moving further, it says, show your solution, all right, to AI, which is what we just did. This is AI on the number line below. So we want to show our solution on the number line. So we want to know, what do we know about this that I have here? It says that x is greater than or equal to 1. I'll use this as a teachable moment just to highlight something to us. What it is I want to highlight is this. Then we'll go back to the question. Now, whenever you're going to represent your ideas on a number line, right? Your ideas on the number line, right? Now, on the number line, you're either going to have an open circle or a closed one like this. So when it closes, it's shaded, right? The shaded one, you can only use the shaded one with the bars, the ones with the bars underneath. And it suggests equal also. So it's either less than or equal, or it's greater than or equal. So whenever the equal is involved, you have to shade. But whenever there is no equal, so it's either less than or greater than, you use this where you don't shade. So there are two types. So we have to focus on our situation. So it's either we're going to shade the circle or we're not going to shade the circle. When it's shaded, it means that the number that you're going to put it over is a part of the solution. That's what this is saying. The number that we're going to include is a part of the solution. And when you put the open one, when you don't shade it, it means that the number is not a part of the solution. All right, so that's the teachable moment I was referring to. Let's go to the question. Now, as you could see, if x is greater than or equal to 1, it means that we're going to be shading our little circle over 1. Positive 1. Make sure you do that, because 1 is a part of your solution. So numbers greater than 1, you have to point in that direction. All you have to do is just point. So you're telling the examiner that answers beginning from number 1 all the way to infinity, going that way, 2, 3, 4, 5, 6, 7, 8 to infinity are a part of the solution. It's not one thing, it's a range of answers. And that it is with when you're doing in equation, you're not finding an answer. You're finding a range of answers that are true to the situation. If you notice, it's a 1-mark question. So they're not expecting too much. Let's take some time to digest that.
Sir,
Somebody,
for A1, you see, sir, for A1,
yes.
you always read from the right to the left.
You read from both sides. I would say to you, read from where the variable is,
Okay.
right? But watch this now. Very good question. This is the important thing now. I would advise you that there is no greater than or less than sign in reality. It depends on where you're reading it from. For example, now if I have x is less than 1, I only say less than because this closed down towards me. If it closed down towards you, you say less than. But if I'm reading it from where 1 is, I would have said 1 is greater than x. And the reason why I can say that is because it opens to me there. So if you're reading it from where it opens to you, you say greater than. But if you're reading it from where it closed down and point towards you, you say less than. So you can read the 1 symbol from 2 sides. But I'll say to you, when you read it from where the variable is, then you get a clearer understanding on the direction in which you want to take. But you can read it from any side. Clear?
Yes, sir.
All right. And the reason why I said the variable is because the questions will be about the variable, about the unknown. So what this was saying to you is x must be greater or equal to 1. So if you read it from that, you're thinking x must be greater. All the answers I'm looking for are greater than or equal to 1. Where are those numbers? Oh, they are these numbers, greater than or equal to 1. So you could see the feel of, you get a good feel of what you're supposed to do right there. All right, thank you for the question, good question. All right, let's continue working. All right, now you do notice what number 2 looks like. It's algebra, right? Number 2 is algebra. Want you to know that. All right, so it says here, expand and simplify. Expand and simplify. I'm gonna rewrite things so that we can have a very good visual of what we're up to, what we're about. All right, so what we're gonna do here is to distribute So we're going to distribute 2x inside the bracket there. We're going to distribute 2x there, -3 there, -3 right there. So we want to distribute those. When you're distributing, try not to make any error. If you do, you're going to be in some serious problems. All right. All right, let's go for that. Now, 2x times x will give you 2x, but the x will be to the second. 2x times 5 will give you positive 10 with the x. -3 times x is -3 with the x. -3 times -4, negative times negative is positive, and that's 12. So now you have that, and what you want to do after having that is just take your time and make sure that you're making no error. So you want to simplify, but I'm only seeing these as like terms right there. We don't have any other like terms, only those. So we're going to write back over 2x squared. Then 10x minus 3x would give me a positive 7x, and the positive 12 would remain. We'll collect 2 marks for that. Good to go?
Yes, sir.
All right. All right, let's continue working. All right. That was a B. All right, yeah. So the C part says simplify. So we want to simplify this that we're looking at. There are many ways you can do this. So what you could do, you could just carry everything on across first. So the top times the top, because you're multiplying. So you could say 3 4s 12. X to the second times x to the third will give you x to the 5th. And all of this must be over 2x. Now you could do the canceling. So I would just say 2 into itself, 1, 2 into 12, 6. X to the 1 cancels itself there, but that 1 power of x is going to take off 1 out of the 5, leaving 4. So what do we have at the top? Basically, we're left with 6x to the 4th. Double check. That's your final answer. Nice 2 marks. Easy thing. All right. I would suggest that's a pretty easy thing for you to collect that 2 marks for that. We don't want to give away those when we get them in the exam. All right. This is warm up. All right. Let's continue working.
Sir, sorry. I'm sorry.
Go ahead, I'm listening.
Please go back down.
All right.
Okay, thanks.
All right, good. All right, I trust that we're understanding. I trust that we're feeling a lot more confident as we go through these papers over time, right? All right, so it says write as a single fraction in its lowest term. No, when they say in its lowest term, you'll be in trouble if you don't give that final answer, which means that you will lose 1 out of that, all right? The instructions are very important, and I'm begging you, read. It says write as a single fraction, which means we don't have a single fraction here. We have 2 fractions there right now, 2, right? At the end of the day, they want 1. So if you're adding fractions, I'll highlight the idea. If you're adding fractions and your denominators are not the same, we normally advise you to do what? Go and find the LCM for both numbers. So the LCM for that would have been 10, right? So 2 into the 10 goes 5 times. So we're going to have 5 times x, that's 5x. 5 times 1, that's 5. Then now, 5, this 5 that I have there, into the 10, and that goes 2 times. So I'll say 2 times 5 give me 10. 2 times negative x give me negative 2x. Now we want to put together the like terms. I would just put them beside each other. 5x and then minus 2x. I have a positive 5, a positive 10, and all of this over 10. My final response 5x minus 2x is 3x. 5 plus 10, that's 15. And all of this over 10. Now, here is the deal. All right, so we have that being, I will break down that to its lowest. Now, this can't go down any further, right? It cannot go down any further based on what we have. So this is the final answer. I'll just advise you, if, and this is a if I could factorize this to get a number that could work with 10, then I would do it. But if I factorize it, I'm going to get 3 out there, and 3 still can't cancel with 10. So you know that you're on your lowest, if you get the point I'm making. All right. So basically.
So sir, is the bottom number 15?
Then you would need to do something again.
Okay.
Right? So currently, let me just express what I'm saying. All right. So currently I have this, right? So currently we have 3x plus 15 over 10. Now, even if you say the top can factorize, right? It can, but it can't work with anything underneath. So the 3 would come out and you will get x plus 5 over 10. The only things that you could cancel would have been this and that. And 3 cannot go into 10 without a remainder. So that is how, when you look at it, you realize that, oh, we're done here. This is the final answer. But as you said, Jody, if this was a number divisible by 3, then it would have been a must that you had to do it. All right. But based on what we have, we're good. We're in good stance. So 2 marks, 3x plus 15 over 10 is good. All right. So there's an E part to this. Let's go for it. Now, let me just say this to you. This is normally a 1 mark question. But whenever they set it a particular way, it turns into 2 marks. Now, this is the difference of 2 squared. But whenever they set it in such a way that you're going to have to factorize 2 times, they give 1 for you to see that. First level of factorization, I always say to you, whenever you're going to factorize, check to see if there is anything in common all the way. And if you do check, you're going to realize that 4 is the highest common factor right now. So if I take my highest common factor out, which is 4, 4 into 4x squared, I'm left with x squared. 4 into -4, I'm left with -1. Now, you see that I've done, this is 1 mark already, because I've done a factorization level. But when I look closely at my part in the bracket here, I'm saying, but this is familiar to me. This is the difference of 2 squares. Now, it means that I have to factorize again, and that is how I'm going to get the next mark, because now the 4 is by itself outside. When I'm factorizing the difference of 2 squares, I'll put the square roots in the bracket. For example, what's the square root of x squared? X. What's the square root of 1? 1. You put a plus, you put a minus, or you put a minus, you put a plus, and you're done. This is the final answer, right? And if you had done it and you get 2x plus 2 and 2x minus 2, you're going to get 1 mark for that, because it's not completely factorized. And I noticed that they made sure that they put the word. This word will force you to do the right thing. It says factorize completely, which means that when you factorize it, we are not supposed to see anything in common inside a bracket. So you have to be careful. All right, as you could see, we picked up some more marks there. Question 2 is fully done. All right. Now, here's what a question 3 looks like. Wow, why am I getting blanks? All right. A question 3 could come in this form. There are many things that could come at question 3, as you'd see over the years. All right, many different things that can come. So this is a scale drawing. Can come at number 3. Comes under measurement. All right. You apply concepts of ratios as you go forward. Let's go for it. The question says here, the diagram below shows a map of an island drawn on a grid of 1 same squares. So they are telling you that these grids are 1 centimeter square, which means that this is 1 centimeter. That's a centimeter. That's a centimeter. That's what they're telling you. All of those little markings, those bright marks, it's 1 centimeter. And we had said this over and over that ordinarily speaking, your graph paper is designed on 1 centimeter, which is like some of us, like your fingernail, if you don't have very big fingernail, like a 1 centimeter square, basically, right? Now, let's see what the question is about. It says state in centimeters. I want to make sure that we are looking at what they're asking. State in centimeters the length of LM, right, as shown on the diagram. Now, the length of LM as shown on the diagram, So the length of LM is for you to count the distance from L to M. Do not make the common mistake a lot of people would make. And I'm going to show you what a lot of people would do. They start counting from L and say 1. No, at L you're at 0, right? So by the time you reach here, 1, 2, 3, 4, 5, 6, 7, 8. Because what you're counting is the space, right? It's not where you stand up, but when you walk, we're counting the space. So when we count, we got 8 right there. So the response for this is 8 centimeters. Everybody good with that? Everybody, are we good getting 8 there? Yeah?
Yes.
All right, good. All right. Allow me to I don't know if I'm going to use this. I might. All right. Give me a second. Let me take a copy of this. Why? Because I might have a question coming up where I possibly don't want to be moving up and down too much, but I could click the screens and we're good. So I'm just going to bring this to the other board quickly. All right. We're there. Here it is. All right. So we have this here. When we're ready, we can just click back and forth. So we are at the question at the same time. All right, like that. All right, good, good. All right. All right, let's see now. Next question, like right here. We don't want to go back and forth. It says estimate by counting squares. Very important to know. Estimate by counting squares the area. We had discussed that this area you're going to count. If you're going to count, my bad, when you're counting, when you're going to find the area on the grid, in reality, is the squares you're going to count. And that is why the unit for area is a square unit, because you're counting square boxes that are within the shape that you're talking about. So watch this. It says estimate by counting squares the area of the map shown on the diagram. So we're going to tell right now how many squares we have. Let me go. I'm going to check it now. All right. So normally what I want you to do is, how much again? Yes, sir, correct. So what you want to do though, is you want to count the solid squares first, and then you want to make up the rest. When you look at them, you could put them together to make one, right? I would say to you, when they're marking a question like this, they're going to know exactly a little range, but not too far, a little range of answers that they would expect you to have, right? So let's count the ones that are fully inside first. So I'll say 1, and normally I mark it for real. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I could count this 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. All right, so I'm just going to call this 33, 34, right? Now, there are a lot of them that we could patch as we go, right? A lot of them. So you could call this 35 along with that little piece, right? I'm just saying. You could call this 36 along with that little piece. All right. You could call this 37 along with this little piece. And that's what we're talking about, you know. You could call this 38 along with this little piece. All right. And as you go, you will see some clearer. I could call this, I'm just saying, so I'm switching. I could just call this 39. I could call this probably 40. All right, with this. I could call this 41 with this. Trying to pick them nicely. I could call this 42 with this. I'm going to get 45. I could call this 43 with any one of these. 44. 45. All right, because you're seeing some little pieces. You could see that little piece and so on. So 45 I'm getting when you put everything together, right? So we're getting about 45 here. So you check, you're going to get something like this. So what you do, you count the solid ones inside, and then you could just look at the others and just classify it as one. And at the end of the day, if you get something like a half or more, and you're done, classify it as one more. That's what we're saying, right? So at the end of the day, you know, you put it together and you work your math out. About 45 squares I'm getting here. So this would have been 45 cm squares. All right, so let's see what they want there. By estimating, so you notice is 1 mark for that. I'm getting 45. I get 45. All right, so you're counting squares per area on these diagrams. All right, let's see what the other question is about. All right, let me see if I could get a more. All right, let's go. All right, so this question now says here, on the island, right, the actual distance LM is, you see this? They're saying the actual distance. Remember, I know, we found out that it was 8 centimeters, and they're saying that 8 centimeters, it is actually 20 kilometers you're looking at. Complete the following statement. Complete the following statement. On the map, 1 centimeter represents how many kilometers? Now, when you go back, you remember that LM on map, I could say on the map, gave us 8 centimeters. But in reality, it was actually 20 km. So I am able to see, I could just divide this to see what 1 centimeter is on the ground for real. So all you have to do is to say, okay, let's divide our 20 km by 8 cm. Look, 8 into itself, 1. So 1 centimeter is at the bottom. So you want to put 8 into 20, and that looks like 2.5 to me. Yes, I think so. 20 divided by 8, 2.5. So put in the measurements there, you're seeing 1 centimeter is 2.5 kilometers. Kilometers at the end already. Very straightforward. They're not asking you to convert anything in. They're asking you to understand that LM was 8 centimeters on the map. And they realize that in that island, when they measure from L to M, they get 20 kilometers. So they're saying, what does 1 centimeter on the map represent in kilometers? 2.5 kilometers. For every 1 centimeter you see on the map, 2.5 kilometers. All right. Now, this part now, write the scale of the map in the form 1, 2. Now, I'll say this to you. The 1 here is always centimeters, okay? Always. It's not maybe, all right? Your graph sheets, your grids, they are just centimeters already because it is very appropriate based on the size of your paper. Now, you see, whenever you see the ratio being used, as in the colon, you have to be in the same unit. Learn that. The colon will force you to be in the same unit. You need the same unit when you see the colon. All right, I don't like that writing. So the colon, I'll say that we need the same unit. And in this case, we have to put everything in centimeters. Now, this is 1 centimeter, which is the same 1 centimeter here. So I'm almost there. I want to just convert 2.5 kilometers. So now think about it. I'm just going to say it's 100,000 centimeter. That's going to give you 1 kilometer. So if I have 2.5 kilometer, all I'm going to do is to say 2.5 times 100,000, right? 2.5 times 100,000, and it's going to give you about 250,000 centimeters. So now we are in the same unit. So we could write it with colon between it. 1 to 250. And you don't have to write back the unit this time because we already agreed. The moment you're using a colon for ratio, you must be of the same unit. So it's 1 to 250,000. But what I'm suggesting is that, you see, they actually led you to the idea. When they ask this here, they're scaling it down to you for you to see what it represents in kilo. And then now you have to do that conversion. So here is when your understanding will come for you to convert that to centimeters so that you are in the same unit, and then the colon can be used. All right. All right, so we're going, moving on. All right, we're going. All right, let's look on the next question. The next question says, what distance on the island will be 3 centimeters on the map? Listen what they're saying. What distance on the island will be 3 centimeters on the map? But remember that we have the relationship already. So remember that we already know that 1 cm is equal to 2.5 km. This 1 cm is for map, and this is what we call actual, or what you call on the island. So then, if they're talking about 3 cm on the map, 3 cm on the map is going to be 3 times 2.5. And this is going to give me about 7.5 kilometers, which is true. For every 1 centimeter, it's 2.5 kilometers. So by the time I have 3 centimeters, I would have reached 7.5 kilometers. There we go. Stepping up the game now, some 1-1 mark question, you know. Here's a 2 mark. It says here, what area on the island will be represented by 3 square centimeters on the map? Very good question. Now, pay attention to details. What area on the map, on the island, should say, what area on the island will be represented by 3 on the map? Let's go to this. Now, what we want to look at is this. All right, so what we want to look at here is this fact that they're asking you if you have 1, 2, 3 of these. See them here? What is it going to be in the real world? And this is on the map. Now, what you're going to have to do is to understand the relationship, right? Understand that the relationship between the two. Understand the relationship between the two. What relationship we're talking? We're talking about, we found out that 1 cm would give 2.5 km. It went further and they told her that 3 cm is 7.5 km. Yeah. Now, but what you want to focus on here is one box. One box. So let us understand what the box represents. So I'm going to put the map is on the inside, 1 by 1. That's how you'll get 1 cm square. 1 length times 1. But in the real world, that one box is going to be 2.5 times 2.5. We are saying, when you step off the map, let me take out the 1. In the real world, it's 2.5 times 2.5 give you a box. So you want to find out how much is that? That looks like about 6.25. All right. So you're talking about 2.5 times 2.5, 6.25. All right. So one of this is actually, hold on. All right, so when we square this, we're getting 6.25. So when we see 1, it is actually 6.25. Yeah? So you have to think about it, 1 on the map, which is 1 by 1, give you 1. But in the real world, that 1 was 2.25, 2.5, you get 2.5 again. So it's a square that you're thinking. So what is that square? So that square is 6.25, the area. Now, let's look at what the question is saying. Check it out now. The question is saying, what area on the island will represent by this? 3 of this. 3. But I know what 1 is. Yeah, I know what 1 is. So if I know what 1 is, then definitely 3 is good. Check it out. 1 is that. So it's like I'll have 6.25, 6.25, 6.25. Let me put it better, clearer. 6.25, 6.25. That's what it will represent in the, but this is in kilometers, All right. So this is not in centi, because remember it's 1 to 2.5 already. We understand that. All right. So you multiply this by 3. Whatever you get.
18.75.
Yep. 18.75. And it is km square. That's what 3 of those little boxes represent in reality out there. So if you know what 1 is, use your scale, all right, that same that they gave you here to tell you what's going on there. And it will take you back to that. So it's 18.75 km and you're done. All right. So that's how they normally develop the idea so that you could break it down. But understand the difference between the map and the real thing. All right. And you're good. 2 marks for that, and we're gone. All right, let's continue working here. All right, hold on. All right, let's go for it. It says the diagram below, not drawn to scale, shows a prism with cross-section. All right, cross-section, let me just mark it for us. They're telling us that this is the cross-section. All right, they said PQRST. That's the cross-section already. All right, so that's the cross-section. And the length 20. So you're seeing the length, that's how long the thing is. All right, no problem. PQRST is made up of a rectangle PQRT, and a semicircle RTS. All right, so we're seeing the rectangle and the semicircle there, the measurements, and we're seeing everything. First question, calculate the area of the cross section. We could talk about it. The area of the cross section is basically, where could I write it? The area of the cross section, I think I'm going to work it here and go back and forth. All right, good. So the area of the cross section, let me write it here for us. By principle, is going to be the area of the semicircle plus the area of the rectangle. That's the area of the cross section. So it's going to be the area of this semicircle here, along with the area of this rectangle here. So all we need to do is just to put these together. All right, so let's go for them. Now, what we want to do is to make sure that we understand that this is diameter 6, which means the radius is 3. All right. So we have, so if the diameter is 6, from here to here is 6, we understand that the radius is 3. Right? So if I'm going to find the area of that, we know what we're going to do. Let's go for it. Area of circle, semicircle. So this is pi r squared over 2. Why? Because it's a semicircle, right? So pi is 3.14 times r squared, which is 3 squared. And when we say square, some of you might say, okay, let's multiply by 3, divide all of that by 2. Let's find out what that is. 3.14 times 9 divided by 2. I'm getting 14.13. So that's the area of the semicircle. Now let's look at the dimension for the rectangle, 5 times 6. Area of the rectangle is length times width, 6 times 5, 30, right? So that's 30. So the cross section, as you could see, is 14.1 plus 30, and that's going to give us 44.13, right? And I believe this is centimeters square. There it is. All right, so you look at what you have, you put it together, and you're ready to go. All right. All right, let's look at the next question. So there is our cross section. Our cross section, we ended up getting 44.13 cm square. We got that cross section. Follow the question now. It says an engineer needs a similar prism whose volume is not more. All right, so the volume is not more than 900. Estimate in centimeters the length of the longest prism he can use, right? All right, what you're gonna do is to understand what's going on. Now, this is a prism, and it's a prism because it has a twin face. So I'll put the other twin face for you. Here's the other twin face. That's the other twin face that you're looking at. So that's it. All right. So what happened is If I find that the area of the cross section, which is this, and I multiply by the length until it reaches here, then I will get the space that it is taking up, which is called volume, right? Now, they are not asking us to find the volume of this. They are giving us a specific instruction. Watch. Now, they're saying that they want a volume that is no more than, so I'm going to use the 900 for a volume. And then they're saying, if it is going to be 900, how long it should be. Understand that volume. We want to take it here that volume is equal to cross section area times length or height, depending on the orientation. So you're going to use substitution now to help you because it's the same shape, they say, except that the length will change. So you're going to put the 900 where it belongs. It's volume, so I'm going to say 900 is equal to the cross section, which is 44.13, times the length that we don't know what it is yet. So in order to find the length, I'm just going to divide by 44.13. So if I have 900 divided by 44.13, I'm going to get that the length that we could use is going to be 20.39. All right, centimeters. So if we use 20.39 centimeters, then we will get the 900. In other words, if I multiply 44.13 times 20.39, it's going to be right there. You might have to round up a little or round down, but try that. It's going to take you there because volume is area of cross section times the height or the length. So 44.13 times 20.39 should show you back something like 900.
899.8, so 900.
Exactly. So they built the question to test your understanding. So they didn't ask you for volume, but they're giving you the volume and want you to find the length. But remember, the formula is wrapped up around cross-section area times the length, and it could be height, and that gives volume. So all I have to do is to substitute, and then from there, I'll take myself out. All right. Now, all right, let's go. Next question. So now we're in the trigonometry now. Let's see what it says. It says here, in the diagram below, not drawn to scale, ST is equal to 6. We're seeing that. WR is 11.2. WT is 14.8. And angle WRS is 90. All right. We're seeing the information there. Calculate, giving your answer to one decimal place. Please note that RS. So they want us to find RS. Now, they want you to find just this right here. But you see, when you look on the diagram, the information that you get, you're going to have to learn to utilize the information. I'm going to tell you what I mean. It's a right angle triangle. I have this side. I have this side. That means I can find all of this side. And if I can find all of that side and then subtract 6 out of it, then I'm going to know what this is. So I'm going to use the Pythagoras theory to find RT. And then I'm going to subtract ST from it, and I'm left with RS. So basically, we can write now that RS is a result of RT t minus 6. So let us go and find RT. Now, RT is one of the short side. It's down here. One of the short side of that right angle triangle. So we start off with the longest side square, 14.8 square is equal to 12.2 square plus RT square. So we're going to calculate our way out. So I have 219.04, which is equal to 125.44. Then you want to subtract 125.44 square from both sides. So it's going to cancel itself on the right side there. So 219.04 minus 125.44, and I'm getting about 93.6, which is RT square. So if I take the square root, of both sides, I'm going to get 9 point something. I get 9.7. So I'm looking at about 9.7. Because I said 1 dp, RT is 9.7. Now we had already said that RS is going to equal to RT minus 6. This is 3.7. Right here is 3.7 meters. So that is how, I mean, when you get the questions, you have to just look, see what you're doing and apply yourself. All right. So the concepts, you have learned them, apply yourself. All right. So
go back a bit, please, sir.
All right.
Go back a bit. You can go ahead.
All right. Now, the next question is to find the measurement of the angle RTW. I'm going to mark the angle first, as always, from RTW, which is this angle here. Moving from R, coming to T, going to W. So the angle is going to always be at the second letter. Now, this is a right angle triangle. All right. And I'm going to use, there are a number, I can use anything, but I'm just going to use opposite and hypotenuse. All right. Opposite and hypotenuse I'm going to be using. So here it is. Remember this? So, ka, tower. So which one of these would have the opposite and the hypotenuse in it? Is sine. I'll just write what it is. Sine of the angle in the right angle triangle is equal to the opposite side over the hypotenuse side. So the sine of the angle that I intend to find right now is going to be the opposite, which is 11.2 over 14.8. Opposite over hypotenuse. 11.2 over 14.8. Let's find what that number is. All right, so let me write up here. So sine of the angle that I want to find has a value of 0.7568. Because I normally go to about 4 dp. So I round off when I reach that fourth one. All right. So now, if I want to find the angle, I'm going to use the inverse now. Sine inverse of 0.7568 Activate your sine inverse. Make sure your calculator is in degree mode. And I'm getting 49.2 degrees. If we're not told anything, we normally use three significant figures. All right, so I'm getting 49.2. And I could have used any one of the rules. Why? Because I had all sides. All right. I could have used cosine. I could have used tangent. I could have used everything, but I won't do all of them right now in the interest of time. All right, good. All right, let me minimize this a little bit. All right. All right, so this one says the graph below shows a triangle ABC and its image A prime, B prime, C prime after undergoing a single transformation. There it is. All right, let's see what the question is. Question says, write down the coordinates of the vertices of ABC. Coordinates of the vertices of ABC. We want to write them down. All right. Where I could write them down. A is 3, 2. A is 3 meets 2 right here. B is 6 meet 2 right there. C is 3 meets 4 right there. So there it is. Looking at the coordinate, they ask us for it. You write them down. All right. Write down the coordinates of the vertices A prime, B prime, C prime. So they're asking you for more coordinates again. A prime, B prime, C prime. I'm going to put it underneath it. A prime is 2 meets -3. B prime 2 meets -6. C prime is going to be 4 meets -3. Everybody could see what this is. All right. So that's the first set. That's the second set. Just reading off, understanding that you have to read the X values first, then the Y values after. Now, question. Again, it says, describe fully the transformation that maps triangle ABC onto A prime, B prime, C prime. 2 marks. Look at it. ABC onto A prime, B prime, C prime. ABC onto this. What would you say? Now, first you want to eliminate some things that are not. For example, when we have an enlargement, there is a change of size. It's not an enlargement. When we have a reflection, we're seeing certain things line up and it's laterally inverted. This is not a reflection. And it's not a translation because translation will not turn, for example, at AC and turn it this way. Translation does not alter the orientation of anything, right? So you're left with, it's a rotation. Now, because we realize it's a rotation, we want to find the center of the rotation, the angle of the rotation, right? So the direction, the angle. So look at the question. They're talking about what move ABC onto, right? So ABC, so this is like our object in this case to this image, right? So what I'm seeing is it's a 90-degree rotation because it's coming from one quadrant to the quadrant next door, only a 90-degree and can do that, or 270 go in the other direction. But we don't talk about 270 too much, so I'll use a 90 for it. So I'm seeing a 90 degrees clockwise because it's moving like the hand of the clock, 90 degrees clockwise. And when you look at this, you would see that it's around 0, 0. Take a look. You could see that for yourself. You should connect these. You will see what's going on. See that? It's a 90 degree around 0, 0. All right? So it's a 90 degree around 0, 0. So I would write this. It's a rotation 90 degrees clockwise about the center 0, 0. That's it. You look, you see it, you describe it. You need an angle, you need a direction, and you need a center. All right. And a lot of times look for 0, 0 first. If it does not look like it, then you could figure out the rest. But then normally 9 out of 10 times it's like a 0, 0. All right, so they're going to give us some work now. So on here it says on the graph, page 16, draw the line x equal 1 and the triangle A double prime, B double prime, C double prime. The image of triangle ABC after a reflection in the line. All right, so we're gonna do a reflection in the line x equal 1. All right, so I'm on this grid, not that, x equal 1. So I'm just gonna do here, x equal 1. So I'm not on the other board, so I'm just gonna use a freehand to draw this. X equal 1 will be this line here. All right, so this is the line where x is equal to 1, and they do ask us to reflect ABC, which is the original thing that we had. So we're gonna reflect it in it. You could employ your counting quickly. Remember, with a mirror, an object is, the distance that an object is to the right of the mirror, it's gonna fall the same, the image will fall the same distance to the left. So you could do the counting and balance. For example, the point A is 1, 2 units to the right. Therefore, it's gonna fall 1, 2 units to the left. So this is gonna be A, 1, 2, triple prime right here. C is 1, 2 units to the right of the mirror line. It's gonna fall 1, 2 units to the left of the mirror line. Then now, B is 1, 2, 3, 4, 5 units to the right. It's gonna fall 1, 2, 3, 4, 5 units to the
Third double prime.
It's triple prime. It's triple prime because there's a double prime already done. Oh, it's double. All right, let me look. Yeah, it's double. All right, thank you. Because I think double prime. Let me double check it. Double prime, yes, double. So let me change it from triple because I think I have triple on it. Thank you for that. Take off 1. All right, there it is. All right, so let's drop this C. No, that's B. All right, we'll just connect the shape. So I'm gonna take off these markings. All right, just to clean the diagram up. All right. All right, and you will take a ruler, not a freehand, ruler. You will make sure that you draw. All right, so there goes the reflection, and that's what it looks like. All right, there it is. So we have a reflection there in this line right there. So you can see that they spoke of rotation, then they give you a reflection, and that's how it goes. All right, let's see what the other question is saying. All right, it says here, state one geometrical relationship between all of these diagrams that you're looking at. I don't have to go back to it. I'm not going to go back to it. It says, when you look at the diagram, you see that they are the same size. You would notice they are the same size. They're all big the same way. So it's coming from ABC, and nothing changed in terms of their size, their area, or anything. So the word that you use to describe things like that is that they are congruent. All right. So we can say that they are congruent. And we're talking about they have the same side length and everything, same angles, everything. And you would have known that based on what you saw. So congruent they are. All right, let's go to the fifth question. So the fifth question said the table below gives the number of cars sold in a country in hundreds. All right, so the number of cars sold in hundreds from 2010 to 2014. We're talking about 2010 to 2014, number of cars sold. So we want to look at that and see if we can maximize, you know, what we're doing there. All right, let's go. Number of cars sold. Let me try to big this up a little bit. All right, number of cars sold. All right, so we're seeing the year cars sold in hundreds. So this is 1,900, 1,000, 2,600, 1,600, 3,000. All of these are hundreds. So you'll attach 2 zeros to the back of these numbers to get the real value, right? First question says what? Complete the line graph on page 18 to represent the given information. All right, so we're going to complete the line graph. So, all right, let's look. We need to plot 13 and 14. 13 is 16, 14 is 30. So let's find those numbers. So based on the scale, you're gonna have to pick 16. All right, so I think I see 16. 16 is gonna be right here. That is 16. You could look over here, take a look at that and examine it properly and look at the counting. You know, so it's 2 lines represent 1 unit over there. So 15 to 16 was right there. Then now I'm gonna go to 30 for the next year, 2014, go all the way up to 30 right here. Then now you take a straight line and you connect this and you connect that. Hold on. Straight line, guys, don't watch mine. All right, that's me trying there. All right, so you connect those. All right, and you have that. So that's you completing the line graph. That's just a line graph. You get 1 mark to do that. So there are questions coming now. It says, between which 2 consecutive years was there the greatest increase in cars sold? Between which 2 consecutive years you saw the greatest increase? Look for yourself. The greatest increase. When did you see the biggest jump? The biggest jump. It looks like 2011 to 2012.
Yeah.
Yeah. All right, 2011 to 2012. And you could subtract here to see the difference. Like we got a 16 jump there. That's the biggest jump we saw. So This is going to be between 2011 to 2012. We saw the biggest jump. Continue moving. What was the total number of cars sold in 5-year period between, in the 5-year period? Now, what you want to do is to add up these. This says that the number, this is cars sold in hundreds. All right, so somebody, let's add these up to know. Please add up these numbers, 19 plus, adding up all of these, adding up all of these. All right, let's see what we get. But remember this, remember what the thing said in it is 100. So if I were you, you have to multiply that by 100 to know the real amount of cars. Because what you're going to get is not the amount. You get 101, but look, I just said cars sold in hundreds. So it's not 19 that was sold.
10,000.
Yeah, because they said cars sold in hundreds. So this is not 19, this is 1900 in reality. So it is 10,100 cars. A lot of people put 101, but in context of the question, you have to be careful. What was the total number of cars sold in the 5 years? 10,100 cars. All right, 10,100 cars were sold. Over the 5 years. All right. Next question. The mean, but remember, you know, the numbers that you're working with, we understand the 101, right? We understand. We're just putting this based on this question here, the total. We just don't want to lose any marks, so we're beefing up our answer based on our understanding of what the table had said, right? But we can understand the 101, what it means, right? All right. All right, good. It says the mean number of cars sold from 010 to 015 was 22,500. See that? See them, they put the 100 at the back. All right. So it's up to you. You can work with it, you know, and understand that it's 100 when you're done. All right. You can put up, yes, when you're finished, you could, you know, attach it to it. So that means when we're ready, if we want, we can work with these numbers. But when we finish, see, they're not leaving it off. Look, they put this at it, telling you 22,500. They told you. All right. How many cars were sold in 2015? 2015 is a year that did not come yet, right? So 2015 would have come here. We don't have any stats for it. But what they did here was they were manipulating the idea and they give you the mean. All right. Now, the mean from when? Watch this. The mean number of cars sold from 010. So originally it was 5 years. Now you're adding one more, making it 6 years. Look, 5 years. We're talking about 1, 2, 3, 4, 5 years. And then 015 would have made it another year. 6 years. So I could do something with this. Watch this. I am going to say, right, that I'm going to turn this into the real number here. 22,500. All right, allow me to change it into that 2,250. This was the total. This is a real number now. Average. But if I want to know the total, you know, before I got the average, here's the idea. Average is going to equal to their total divided by the, which is the total number of years. So you're talking about 2,250 equal to what we intend to find over 6. It's 6. Because it was a certain total that divided by 6 that gave you this. So you can find back that total by multiplying. Watch this now. So it is called the aggregate. right? That's sum. So let's put sum if you want. All right, we could put sum here. Because when you're going to do the average, you know, you're going to find the sum, it's an aggregate, over, in this case, the number of years, right? In this case. All right, so that is how you got that. So now, we're suggesting that you could say 2,250 times 6 will give you that sum. And that sum will include 2015. 2,250 times 6 is going to tell us that, listen, it's 13,500 cars from 2010 to 15. But we have knowledge that up to, see there, up to 2014, it was just 10,100. So now I can know how many cars were sold in that 1 year. Because so now I could say 2015 cars sold will be 13,500, take away 10,100. Tell me if you see what we're going with there. So I was able to do that, and now I'm getting 3,400 cars. Because I played with the idea of average, just to know what was the total sum. Before you divide by the number of years, you must have a total. So if you multiply the number of years by your average, it's going to tell you the total. And then I compare the two total. This one was up to 2014, and this one is up to 2015. Then I could know what happens between 14 to 15. You subtract them. So there were 3,400 cars in 2015. And that is how a lot of times they want you to put together the idea as you go forward. All right? All right. Continue working. Coordinate geometry. It says a line J, talking about a line JK as the equation 2y equal to 5x. Let me see if I could blow up this bigger. All right, good. So 2y equal to 5x plus 6, determine the gradient of JK. Now, if you're going to determine the gradient of a line, please ensure that y is alone. Put it in the form y is equal to mx plus c. So in other words, I have 2y, which is equal to 5x plus 6. I'm going to divide by 2. So when I divide by 2, I have y is equal to 5 over 2x plus 3. Remember that the gradient is the coefficient of the x. The gradient is the m. And in this case, it's 5 over 2. So I'm just going to conclude that the gradient is equal to 5 over 2. So I would not want to take the gradient when it is in that form. You want to take the gradient when it's in the form y equal to mx plus c. Matter of fact, this is called the gradient and intercept form, or what they call slope intercept. Slope is a gradient, and this is the intercept. So if you want to tell the gradient, you want to put it in the slope intercept form, so you could pick the gradient. It's going to be m all the time. All right, let us focus on some more questions. So the next question says here, another line J is perpendicular to JK and pass through the point 5, -1. Another line GH should say. So state the gradient of GH. All right. Now, there's a relationship when lines are perpendicular. When lines are perpendicular, one gradient is a negative reciprocal of the other. So then all I have to do, since that gradient that we had up top was 5 over 2, and this line is perpendicular, so the gradient of this is going to be negative, and you turn this upside down, you get 2/5. So the gradient here, the gradient of the line GH is negative 2/5. It's a negative reciprocal of that we got. Now that we have that, right? It says determine the equation. Now, if I'm going to determine the equation of a line, all I need is one, I need the gradient, and I need the y-intercept. And the y-intercept, we call it C. We don't know it yet. So I could utilize what I have to find it. I'm going to be using y equal to mx plus c. Now, I have a point here, which is 5, 1, 5.
Josh?
So I could use the point.
Yeah, they fall them a kill them one another. They go lock them up here, man.
Ishmael, mute your mic. So 5, negative 1.
Oh, Jesus.
So we have x, we have y. So we're going to substitute the gradient along with the points x and y in this form and find c. So negative 1 goes where y is. M, negative 2/5. X, sorry, times 5 plus c. So we substitute one coordinate with the points, the coordinates for the point 5, negative 1. Using the gradient. And then we're going to find c. Luckily we can cancel here. 5 into 7 one time, 5 into that 1. So we have negative 1, which is equal to negative 2 times 1 is still negative 2 plus c. Sorry, what I'm going to do now, I'm going to add 2 to both sides. So I'll have 1 equal to c. So I know that c is 1. So watch this. C is 1. M is equal to negative 2/5. If you have your gradient and your intercept, then you could simply say y is equal to negative 2/5 beside the x, positive 1. We're done. So that is the equation of GH. All right. Go to the next question. We're at number 6. We're traveling. Number 6 comes, statistics comes at number 6 every year. So it says the table below shows how the minutes taken by all 11 students to complete a science experiment were recorded and grouped. You're seeing it down there. Complete the cumulative frequency column in the table. So we're doing the things one at a time. We're going to complete the cumulative frequency now. Ordinarily speaking, your cumulative frequency, your first value starts your cumulative frequency. So your first frequency, start the cumulative frequency. Then you could do a adding thing going on to that like that. So 1 plus 2 give you 3. 3 plus 5 give you 8. 8 plus 7 give you 15. 15 plus 10 give you 25. 25 plus 15 give you 40. 40 plus 8 give you 48. 48 plus 2 give you 50. And it means that we're dealing with 50 people, right? So we're handling 50 people in a table right now. So it's a cumulative frequency table. So you add your current row to the frequency after that, and you keep getting the cumulative, you're adding up, right? At the end, it normally tell you how many things you're dealing with right there, 50. All right, let's see what they want. So we would have collected 2 marks there just to do the cumulative frequency. On the grid on page 23, using a scale of 2 centimeters to represent 5 minutes, all right, on the X, and 2 centimeters represent 5 students on the Y-axis. Draw a cumulative frequency curve to represent the information. All right. So we're going to do that. Now, our cumulative frequency curve is done against the upper boundary, not these numbers. So I'm going to create the upper boundary here right there. I'm going to be adding 0.5. So this is 5.5, 10.5, 15.5, 20.5, 25.5, 30.5, 35.5, and 40.5. So here it is, we have our upper boundary. When you're going to plot a cumulative frequency curve, it is plot using the upper boundary and the cumulative frequency, right? Sorry about that. The upper boundary and the cumulative frequency. So let's continue looking. So we're gonna put on the scale and we're gonna come, all right. Maybe I don't wanna go back and forth. Allow me to do this, give me 1 second. Give me a minute. Let me minimize this graph. Let me take it to the other table. One second. I think I have bad quality there. All right. All right. Let me try working. All right, let's go back to this. I don't think I like the quality of that. All right, let's go. All right, I'll go up and down. I don't like the quality I just saw. All right, so we have 5.5. So let us put on the labeling first. So look at the label. So I'll push this up. So the label says we're gonna go 2 centimeters to 5 on both axes, but you're gonna have minutes on the X and the number of students on the Y. Let's put those on. So on this axis, I'm gonna have minutes. And on the other one, I'll have the number of students. They said 2 to 5. So we have 5, 10 after every 2, 15, 5, 10, 15, 20, 25, 30, 35, 40. And then on the other axis, 5, 10, 15, 20, after every 2, 25, 30, 35, 40, 45, 50. All right, so there it is, we have those. So what we want to do now is to plot these values, right? So I'm going to just grab them one time. I'm going to use my phone just to have them so I don't have to go back and forth. Maybe I should have brought that to the other table. I could have. All right. All right, I'm putting this one on this here, and then I'll use the better graph for the other one. All right, so I could look at the numbers here quick. All right, good. All right, let's go back. So, all right, here's a graph. So let's plot our points. All right, remember now it's the upper boundary with the cumulative frequency. So we're gonna skip over the frequency, guys. Upper boundary. We're going all the way from here to here. All right, all the way. All right, so 5.5 with 1. So the only thing is you need to know where 1 is. So you're seeing here that on these axes that we have, both of them is the same scale. 2 of the little lines represent 1. On the x-axis, 2 of the little lines represent 1. That means 1 of the little line is 0.5. All right, 1 of the little line is 0.5. So we are plotting 5.5 with 1. 5.5 with 1 is right here. All right, then I think we're gonna go 10.5 with 3. 10.5 with 1. 3 is about here. 15.5 with 8. 20.5 with 15. 25.5 with 25. All right, so we see our shape coming out nicely. 30.5 with 40. $35.5 with 48. And then 50.5 with 50. Right there. Understood. All right. So what we're going to do now is just to draw our curve. This is what we have. All right, so there it is. Right there, kind of miss right there. All right, let me see if I can. I hope it doesn't disappear. Ah, it will. All right, give me 1 second. All right, so there it is, a better diagram. All right, so that's our cumulative frequency curve there that you're looking at. All right, and whenever you do it, it's always gonna have that shape every time. So whenever we have this now, they can now ask a number of questions from it. So you draw your cumulative frequency curve. It is done against the upper boundary, and then now we could respond to whatever questions they intend to ask, right? Let us now see what else they want. Oh, it's done. All right, so they didn't ask anything from it, no? Oh, here are the questions, good. So here are the questions. So you got 5 marks to do this, you know? 5 marks to do that. Questions are as follows, and it says, using the graph, right? They're asking us to, 1, estimate the median time taken to complete the exam. Remember, the median refers to 50% of your sample, and this is called our Q2. So you're going to find 50% off. It's 50 persons. So 50% of 50 is going to give us 25, but this is not the answer. You're going to use the 25 now to answer the questions. So I believe I have to take this graph. Maybe I have to take this one to the board for real. All right, so in order to answer this properly, let's take the graph to the other board. Here it is. All right, I think that could work. 1 second. All right. All right, let's see if we can respond to a few questions here from this, right? All right, let's go. So here's the first question. 50%. So we're going to find 25. 25 here. Take 25 to the graph. And then right where it touches the graph, you want to take it down and then you read off. All right. So that's the idea we are saying. I think I'm getting, so we take 25 here and then I read off. And whatever you get, yeah, you work with it, right? So I'm getting about 25.5. When you come down, I'm coming down at 25.5. So my median is 25.5, which is this right there. That's 25.5. Came down on one line in front of 25. All right. So that's my median. 25.5. Let's look good, man. Next question says the probability that a student chose not random took 30 minutes or less to complete the test. So that's under 30. Under 30 minutes or less. So you want to go under 30. So you go to your curve, go where the minutes are. It's on the x-axis. So we're talking about 30 minutes or less. All right. So we want to know how many students first, and then we deal with the probability after that. All right. So we'll go where 30 is. This is 30. Carry the line up. The moment it touches the curve, I'm going to stop right there. Right there. And then now I want to take that to the next axis. Okay, it looked like 39 to me. All right. All right. So based on what I'm seeing, like about 39 right there. All right. In the exam, it's going to be very brighter than that. That's a little bit pale. So it looks like 39. So what I'm going to do is to remember the context of the question. Say 39. But probability is the key word here. So because this is probability, you can't just put 39. Probability cannot be more than 1. So it is 39 out of the total, which was actually 50. So this is the reason why they give 2 marks. If you put 39, they give you 1. If you put 50, you get 1. But if you put 39 over 50, you get both. That's the probability. All right. All right, so they are saying show, see here, show on your graph, they said using the broken lines. So when you're drawing your thing, those lines that you see that I'm drawing, you'll use your ruler and just do that. They want to see that. They wanted to see you going across broken lines. So they're actually telling you here. And even if you're not told, use broken lines, right? Use broken lines. So they're telling you that they wanted to use broken lines, right? See there? So use broken lines to draw on your graph when you're going to show them what you're doing. Question 6 is done. All right, there it is. So I guess we're at number 7. We're traveling, soon finish. Number 7, as always, is going to be what we call an observation. Number 7 is observation. So you look, see what the pattern is, and then you produce. All right? I'm using freehand here. All right, so it says draw the 4th. Look at it, observe everything, and you want to do yours just like this. So the 4th one would have 4 of these. Look at the sides. It finish it in 3 boxes, like and you put your little thing on the edge like these, You do your cross up. So you do all 4. Remember, you're not going to use freehand, you know. So I'm just sketching this quickly for you. But in the exam, you're going to do the real thing. All right, so you'd have done something like that. And they normally give you 2 marks to start that off. All right, so you get your 2 marks, and that's that. Now, here comes a table, always. So it says the table below shows, the number of dots and lines in each figure. Study the pattern in the table and complete the table by inserting the missing values in the rows and at I, and that IV. So there are some missing things, you could fill them out as you go. So you want to look for pattern. I'm seeing where we are actually adding 3 going down there. You're adding 3, adding 3. I'm adding 5. Adding. So this is 13. This is 21. So for these 2 marks, you don't need any big thing based on what you're noticing. But when you skip and go down, it starts to get a little bit more hectic, where you're gonna have to try to figure out the pattern. But I said to you, there's a way that we have been doing where we don't need to try to figure out, because they're always gonna have the end at the bottom. So we are suggesting that in this class, we wanna fill out these first, fill out that end down the bottom, and then it's gonna help you to just find everything else, because we have 1, 2, 3, 4, about 4 or 5 things to do. Why not find out the pattern that moves figure 1 to the number of dots, from the figures to the number of lines? We're gonna do that right now, right? So how did we say we do it? All right. What we found out was if we have a common difference, which means that you're seeing that there is a constant thing being added, like in this case, we're adding 3. The moment I see that, I could figure out for that column, the missing thing here. And it's going to be in the form of an n, right? Because it's a generalization we're doing now. So this is how we work them out. So we're focusing on finding out the nth column down the bottom. So I'm going to do this. Number 1, we're going to write A is the first term, which is 4. D stands for the difference between the consecutive terms that you see if it is constant. If it is not the same thing, we can't do this. All right, so the difference is 3. So we're going to set up this A plus n minus 1 d. And this will tell us the pattern that moves from figure to number of dots. A, let's substitute 4 plus n minus 1 d is 3. We're going to distribute that 3 inside. So right back your 4. 3 times n becomes 3n. 3 times negative 1, negative 3. Simplify this right now. 3n plus 1. So sometimes you might not figure out this quickly. 3n plus 1 goes here. This is saying 3n plus 1. So if I know anything in the figure column, 3 times it plus 1 takes me to this column. That's what this is saying. So that means where 10 is, we could figure out what's going on there, because you say, okay, 3 times 10 plus 1, and this is going to give me 31. We could figure out now. And you could try all the others, but you don't have to waste time on that. You understand? But there it is. We're figuring out that I could just snap my fingers and get it, right? What I'm going to do is to fill out the other missing spot over there too. And then from there, there's nothing that they can stop us with, right? Let's figure out that first. The other spot over here. We want to figure out that spot. Now let's look in the column at the top if there's a common difference. Look, 6 turns 11, and then 11 turns 16. We're adding 5. Because there is a common difference of 5, I could use this. A is the first term, it is 6. D is the common difference, it is 5. The general formula is developed by using A plus n minus 1 with D out there. We're going to substitute A, 6, plus, in bracket, n minus 1, D is 5. We're going to distribute the 5 into n minus 1. Let's write back 6. 5 times n becomes 5n. 5 times negative 1 becomes negative 5. Simplify everything now. 5n plus 1. So you see, this one is 5n plus 1. Sometimes it's not so easy for you to just pick it up. So it's best to utilize this and just go quickly. 5n plus 1. So now that I have those things at the bottom, I could just navigate now. If I wanna find that missing spot over here, what takes me from the first column to all the way over there is gonna be 5 times 10 plus 1. That's gonna give me 51. Just like that. So now that I know the formula to move from the figures to any column, then I could just roll through. Now, since I have 49 here, I'm going to go backwards. So I'm in the second column, which is 3n plus 1. So it means that I could say 3n plus 1 was equal to 49. And then I solve it for n, because I'm going to come to this column. I want the nth. So then you're doing a regular math. How do you solve that? 3n plus 1 give you 49. Subtract 1 from both sides. So 3n is equal to 48. Then you divide by 3. So n is equal to 16. 16. So you see that? We get the 16. So we could use it to go forward. And if they gave me the one forward already, I still equate it to my formula and then go backwards to it. Right? So now that I know 16, I can now use the 16 with the 5n plus 1 to find the missing thing in that column. Here it is. 5 times 16. That's about 80 plus 1 becomes 81. So there it is. We have that. And it seems as if the table is fully completed. So you can see that the moment we get these, they're always going to be down the bottom. Check them out first. And when you get them, navigation gets easy. All right. It is completely difficult at times to be trying to figure out what works. You're guessing. You don't need to guess. As long as there is a common difference between the terms, you could utilize this idea and it takes you there. All right. I hope that resonates something in you. All right. We're at number 8. We're traveling. As you could see, we're moving. Number 8. What does number 8 says? Number 8 says here, the diagram below shows the graph of 3 lines, right? Diagram below shows the graph of 3 lines and a shaded region S defined by the 3 inequalities associated with the lines. All right. The inequality associated with the line y equal 3 is y is greater than or equal to 3. All right, so they're giving us some clues, right? All right, let's see what they want. Say the 2 inequalities which define the shaded region. The other 2. What I'll say to you for a teachable moment is that you will not find inequalities here. These are lines, and lines are represented by an equation. An inequality is a region. Now, whenever we're going to interpret our inequalities, read from where the variable is. And if you have 2 variables, read from where y is. Y is more important than x in the reading of this. So now, watch this. We're going to be using a simple idea. If you are reading where y is less than or equal to, you're going to shade under the line. That's what it means, under a line. If you see something where y is greater than or equal to, you go above the line. So greater than will be associated with above the slant line. And if it is less than, it's underneath. But you would know if you have vertical or horizontal lines, you will know numbers. For example, this line, x is equal to 2. We already know the numbers greater than 2. They go that way. So that's not a problem. All right. And this other line where it says y is equal to 3. We know numbers less than 3 and greater than 3, straightforward. It's the slant lines that will cause the problem. So with the slant lines, you go above or below the line, depending. Now, look at this. They gave us this one. We are to produce this. That one is coming from x is what? Greater than or equal to 2. Why? Because it's a solid line, which means a bar is underneath it. And the shaded region was to the right. Look for yourself. The shaded region was to the right. And that is why my red arrow is in the black spot now. So for that line, it was representing things from 2 going to the right. So you could see that going to the right of 2, those numbers are greater than or equal to 2. Hence, that's one of the inequality. For this slant line here that says x plus y with a 10, it's going to be less than or equal to. Why? Because the shading was underneath the line. Underneath the line. So the moment the shading is underneath the line, it is coming from less than. The line is a solid line, so you have equal attached to it. Where are our 2 inequalities? As follows. X is greater than or equal to 2. That's 1. X plus y is less than or equal to 10. So those are the 2 other inequalities that we could have used. And everything is in context of the shading, right? So the shading S here would have given us the clue because it helps us to see whether or not the shading was above or below or on top or underneath, to the right or to the left. We were able to see that. And then we could come up with our equalities. So that's what they want to see from you as you work. Those are some of the stuff that they want to see. All right, let's continue working. Next question. It says the function p equal 5x plus 2y minus 3 satisfies the solution set represented by the closed triangle. That is a closed triangle. See the triangle shaded there? That's the solution. So now it says identify the three pairs of x and y. Coordinates they're referring to from the vertices of the triangle. They come from the vertices, all right, for which p has a maximum or a minimum value. Now identify the three. Watch. What? So they're asking you to pick up the vertices. Here they are. There's 1, there's 2, and there's 3. Take them off. We want to use them. So if you don't see numbers and you want to put on numbers, put them on. This is a 7. So you get the missing numbers that you think you need, put them on. This is a 3. So in terms of coordinate, one of them is a 2 meets 3, which is right here. Then we have a 2 meets 8. And then we have a 7 meets 3. So we have a 2 meets 3, 2 meets 8, and a 7 meets 3. So those are the answers that they're looking for here. 2, 3, 2, 8, and I think it was a 7, 3.
Yes, sir. 7, 3.
And 7, 3. Very simple. Identify the three pairs of x, y values, which p has a max or min. Remember, we had said earlier that, when I said earlier, I mean in class, the solution region, the best and the worst is on the vertices. The best and the worst, they are right here. They are not inside. They are on the edge, the best and the worst. One of them is the best and one of them is the worst. All of these on the inside are solutions, but they are not the best. They are not the worst, but they are solutions. They do make profit, but they are not the best and they are not the worst. All right. So now let's see the context now. What else they want? Which pair of coordinate x and y, all right, makes p maximum? Justify your answer. The justification is simply you're working out. All right. So you're going to work out using the profit function. Let's go for the profit. P. The P function says 5x plus 2y minus 3. Let me write it. 5x plus 2y minus 3. And we're going to do it right here as well. 5x plus 2y minus 3. And we're going to do it right here. So 5x plus 2y minus 3. We're going to do it all 3 places. All right. Here are the vertices. We're going to try 2, 3 there. This is x, this is y. So what are we talking about? 5 times 2 plus 2 times 3. I am picking on my coordinate, x, y. X, y. Then we're going to take 3 from it. 10. Let me write the 10 better for you. Let's come again. 10 plus 6 minus 3. 16 minus 3, that is 13. All right? So that's 13 that we're talking there. All right, let me take out the dollar sign, maximum value. 13. Now, the next point that we're going to be looking at is 2, 8. X, y. 5 times 2 plus 2 times 8 minus 3. 10 plus 16, that's 26, minus 3, that's 23. Next, we're looking at 7, 3. X, y. 5 times 7 plus 2 times 3 minus 3, 35 plus 6, 41 minus 3, that's about 48. Now, respond to the question.
Sir,
Right? Yes.
you sure it's not 38?
48.
Where? Yes, 38.
Yeah.
Where it is. Yeah, man, this is 38. All right, 41 minus 3, 38. Thank you for that, for seeing that quickly. All right. So now when you work out that, all right, what do we have there?
You'll be 73, sir.
Exactly. Now, they want, watch what they said, you know, which pair, XY, you understand? So they could ask, so right now the answer is 73. Hear what I'm saying? Please be advised that what you don't want to do is to say 38 right here. You're going to be wrong because they could have asked for the maximum value, then it is 38. They could have, so you have to look for what they want. Pay attention, because they could ask for anything. So this time they want the pair. So you tell them, that is it, 73. Don't tell them 38 now. We know that 38 is what justify what we're doing. All right? And that is what you pick and you go. All right, so there it is, 7-3. And we have that. And what else is coming up? We're in functions now. We're going. So it says f of x, the function f of x and g of x are defined as follows. F of x is equal to 3 open bracket, no, 3 over 2x plus 1, and g of x is equal to x squared. Evaluate g of negative a half. No, no problem. This is the g function. The g function is x squared. So if I'm going to do g of negative a half, it means then negative a half will go where the x is and you square. Negative 1 square is 1. 2 square is 2. So we're getting a quarter there for that. So g of negative a half gives us a quarter. Are we good with that? Yes, I should think so. Now, the next question says we're doing a composite function. We're doing f of g of negative a half. Well, the reason why I like this is because I have already found out what g of negative a half is. So then I could now just quickly represent my idea, because f of g of negative a half is going to actually mean f of a quarter. In other words, because g of negative a half, hold on, because g of negative a half is equal to a quarter, then basically at the end, I'm going to find f of a quarter. So here it is, I'm going to put it at the side. F of x is 3 over 2x plus 1. So basically 3 over 2x, right? All right, let me put this underneath. F of a quarter, yeah, is going to be 3 over 2 times a quarter plus 1. So let's go again. 3 over, let's cancel, all right? So we could cancel this. 2 into itself, 1, 2 into this half, all right? So we end up with a half. Underneath, you have a half plus 1, right? Hope everybody's seen that. So technically, you're seeing 3 over 1.5, which is 3 over 2. So you have 3 over that. 3 over 3 over 2, or 3 over 1.5. All right, same thing. So let me write it for somebody else. You might say 3 over 1.5, right? And the answer is 2. All right, so the answer is actually 2 for that. There we go. The second part says write an expression in X for the inverse of the F function. So we want to start off with this. This is the F function. And I'm going to say to them, I'm going to just tell them to let F of X equal Y such that I'm going to rewrite this using Y, such that Y now is equal to 3 over 2x plus 1. So I'm telling them that, listen, I'm going to switch that F of X there because I'm going to do something with that inverse thing, right? So the inverse first step is that you're going to switch X and Y. So where Y is, I'm going to put X, I'm going to put here. So it's going to be X equal to 3 over 2Y plus 1. So that is us switching X and Y. Then transpose now for the new Y. So that means you're not going to work with the fraction. You're going to multiply this by 2Y plus 1. You're going to multiply the other side by 2Y plus 1. It's a binomial. Do that. On the right side, the 2Y plus 1 cancel, right? So you're going to distribute. No, we're going to distribute now. On this side, we're going to distribute that X in there. So you'd have 2XY plus X, which is equal to 3. All right, so that's what we have. From here now, we could start moving, right? The intention is to find Y. This is what we want to find. So if that is the intention, to find Y, then take your time. We're going to subtract X from both sides, yeah? Rewrite what we have. So we have 2XY, which is equal to 3 minus X. Then I'm going to divide this side by 2X, because it's Y I want to find. And there is the Y alone. But they didn't ask me for Y, so I'm going to finalize the question and says, the inverse of F of X is 3 minus X over 2X. And here is my solution right there. They're giving all of 4 marks to do that. Good to go?
Yes, sir.
All right. Good. All right, good to go. Good, 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 good. Continue working. Soon finish. This is number 9. We finish at 10. All right, so number 9 is measurement, geometry, and trigonometry. All right, so let's see what goes on. The figure below, not drawn to scale, shows a circle of center O. The radius of the circle is 21, and the angle HOK is 40. Take a look, we're seeing it. Pi is used as 22 over 7. What do they want? They want us to determine the area of the minor sector. Area of the minor sector. All right, no problem. Area of the minor sector. Now, the minor sector area is the entire thing here. That cut of cheese, that thing that looks like a nice cut of cheese, that thing that looks like a nice cut of cheese is what we call the sector. All of that, right? That's what we're about to find. Let's clear this up. Let's go for it. The formula is that the sector is going to be the angle over 360 multiplied by pi r squared. So it is actually a portion of the area of the circle. Now the portion is going to be 40 degrees out of the 360 multiplied by pi times r times r. Now quickly we could take our calculator and just assist ourselves. 40 times 22 times 21 times 21. All right. I'm just writing out numbers at the top, numbers at the bottom. See with me. Showing some steps here. Make sure that I'm correct. Keep me Keep me correct, people.
Correct, sir.
All right. So at the bottom now is going to be 2,520. So we're going to divide 388 is 080. We're going to divide that at 2,520. And I'm getting about 154 cm square. 154, right? So that's 154 square centimeters we're looking at for that. And it's just a simple formula. What is the formula? This. Do you get this formula from CXC? Yes. Do I need to memorize it? No. You get this formula. So all you have to do is to know when to use it, utilize it, and you're good. All right. Let us keep working, keep working, keep working. We're not going to stop until we're done. The area of the triangle. The area of the triangle can be found using the sine formula. Remember we said that if I have a triangle, this is 21, this is 21, and this is 40. Now, trigonometry helps you to find the area of a triangle when there is an angle between two known sides, right? So the moment we have an angle between two known sides, trigonometry says to you, area of that triangle is going to equal to half AB sine of the angle there. So in this context, when we talk about half AB, we're talking about 21 times 21 times the sine of the angle, which is 40. So these are the same numbers that are here. See them there? They are the ones that we're using, right? So now is your calculator that you're going to use to take you out. 21 times 21 should give you about 441. Divide that by 2, then multiply that by the sine of 40 degrees. Make sure your calculator is in degree mode, and you're looking at getting 141.7. All right, and it is the area, so it is going to be square centimeters there. So we have the area of the triangle. And then nicely, as you could see, they want to know the area of the shaded region. Now let's take a look at what we're dealing with, right? You're dealing with the sector, and then you're dealing with the triangle. You do notice that if you pull the triangle off the sector, you're only going to be left with this little piece. This is called a segment by definition. It's a segment. It's a shaded region right now. So that is by pulling the triangle off. See? So the sector is a triangle combined with that. So if I pull off the triangle by subtraction, I'm left with the shaded portion. The correct name for it, as I said, is called a segment. They might ask you about a segment next time. So here is the deal. That we want to say the area of, oh, they did say shaded segment, my bad. The area of the shaded segment is going to equal to, by formula, area of sector minus area of triangle. Now we're talking about 154 minus 141.7. Put it together, guys, and we're good to go. 12.3. Thank you very much. The exam does not get harder than this. As long as you are practicing as often as you ought to, you know, catching in the working out, watching up your necessary videos, take the time out to go through, you should be fine. All right, let's see what the next question is about. If you don't know, I'm streaming live on YouTube still, so the recording would be there. All right, so you go to YouTube, you could rewatch it. All right, so here's the deal. We're saying now that the diagram below, so we're at circle theorem now. The diagram below not drawn to scale. All right, that means don't try to figure out things by looking at it without proper mathematical given definitions and ideas. All right, don't just look and say, oh, this looks like it's half of that. We're not going to do that. So it's not drawn to scale, but we're told that the center is O. Very important. O is the center. All right, so I like the fact that we're told that O is the center. Now, TAE is a tangent. So we're told that this is a tangent. And a tangent just kisses the circle at a point, and it kisses it at the point A. This is the point of tangency. Right. Now, also we have the angle AOD, which is 72 right there. So they gave us a number of information. Now let's see what it is that we can do, what it is that they want. So the question went further and it says calculate giving the reason for each step. So you're going to give the reason for each step, the measure of ADC. ADC. By principle, we mark our angles first. ADC. Where's A? Where's D? Where's C? I would want to mark my angle right here. That's AD. Oh, is it ADC? Hold on. I think I'm doing AD. Let me look. ADC. Hold on. Oh, I think I could just continue. ADC. Hold on. Where is my marker? ADC goes all the way to here. All of that angle, and let me just put a little thing here. For all of that little piece right there, that's ADC. Now remember, a nice thing that we got was the center. So that means that this is diameter. So any line that passes from one point on the circumference through the center to another point is actually the diameter. And then now remember, angle in a semicircle is 90 degrees. ADC is 90 degrees, right? So ADC is 90. And the reason that we're going to use is that angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. All right, not bad, not bad. ACD, ACD, mark the angle first. ACD, ACD, right here. Yes, sir. Eh? Now, remember, one of the things you can do to trigger your memory, because you have to trigger your memory when it comes on to, I'll say to you, when it comes on to the circle theory, you're not doing a lot of working, but you're going to have to remember what would have led to the answers that you're getting when you give them. So if you get 2 marks and you don't tell them how you got it, then you're going to lose 1, and you don't want to lose any. So to trigger your memory, you could do this. And I'm just saying this works most times. Find out where the angle developed from. The angle that you want to find. Look, it's taking me all the way to A. It's taking me all the way to D. So now you're seeing that the angle that you want to find at C was developed at A and D. So then you want to think, what else am I seeing coming from A and D? And if you look carefully, you're going to notice that, hold on, I do see 72. Go to the center. So now you want to think, what rule link angle at the center to angle at the circumference? And that is going to drive that knowledge, right? So the angle at the center was coming from the exact same place as the angle at the circumference for C. So then we're going to write this now and say, all right, 72 divided by 2 is equal to 36 degrees. How do I know? This is the rule. It says angle at center is twice angle at circumference. Yep. So as I said to you, always try to trigger yourself, like try to help yourself to remember. Follow where the angle came from. A lot of times you're going to see something that will give you a clue. But this is based on the fact that you would have spent time knowing those rules. Angle at the center is 2 times the angle at the circumference. Let's go for the next one. CAD. CAD, CAD. Mark the angle CAD. CAD is this. Now, there are 3 angles in a triangle all the time. And right now, looking at CAD, it's a triangle where we have 2 angles out of the 3. We have the right angle that we knew. We have 36. Therefore, CAD is going to equal to 180 minus the sum of the other 2 angles in that same triangle. So it's 180 minus 126.
Which
right?
is 54.
Exactly. And we're looking at 54 degrees. Now, what's the rule? I'll simply say total interior angle of a triangle is 180. I was able to utilize the total interior angle of the triangle, which is 180, to put together the other 2, take it from it, and we're good. Not bad. Circle theorem is a nice little thing to get marks as long as you're going through your notes. Let's mark OEA. 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 Right there. We want to find OEA right here. All right. So when you look at this, I mean, there are a number of ways that you could try to get there, right? So think about, yes, you were saying something?
Oh, no, sir, you can go ahead. I was going to say that 2 angles are already there, basically.
Okay. Well, it's not basically, it is there. You are right. 2 angles are there. But I'm going to highlight the triangle that you have to focus on. So I'm going to take off that. And then I'm going to take off that. I'm highlighting the triangle. Because you see, each time these things come up, you're going to have to focus on the right material. Here's a triangle of focus. That's it, you know? That triangle right there. Just like what they said, the triangle OEA. Look at OEA. I have 72 up there, right? So I'm going to take it off now because it's dark. I should have used, let me use a lighter color. So we're focusing. So we have 72. Now, when a diameter meets a tangent, everybody remember what that is? Diameter meet tangent at 90 degrees. So you say if you remember that piece, you're nice. If you don't remember that, you're going to struggle. Let me write it back. When a diameter or radius meet a tangent, you get 90 degrees. So then this little angle here is simply 180 minus the 90 plus the 72. 180 minus 162.
18.
18. This angle there is 18, right? So that is 18 we're looking at. Now we get 18 for that angle there. What did we do? We do a number of things. We're talking about diameter meets tangent at 90 degrees. And finally, we said total interior angle of a triangle is 180 degrees. You're done. We were able to navigate, put in the work, do what you have to do. And this question comes every year.
Sir, just a second. Can you just go back to the answers? Let me take a picture, please. Right there.
Okay. Remember, it's going to be up though, remember. Good?
Yes, sir. Thank you.
All right. All right. So the last question now, number 10. The last question is always vector and matrices. Syllabus completed, done. All right. Vector and matrices. So let us see what they want from us. Let's go. It says the points A, B, and C, right? The points A, B, and C have coordinates -2, 8, B, 4, 2, C, 0, 9. M is the midpoint of the line AB. Make note, AB. Express each of the following in the form X over Y. This is what we call column matrix. This is just a column matrix, right? And vectors are represented in column matrix if you're going to be using matrices. If you're not using algebra, it's represented here. Now, the moment you have a position vector system, right? The coordinates of the point is indirectly the position vector. So B is 4, 2. So OB is 4, 2 in that form. Now, so that's that, very simple, straightforward. Now, the next question says, find express AB now. To express AB, you're going to have to understand that you're going to move from A to O, plus you're going to move from O to B. Why? Why did I say that? I only say that because we realize that we're dealing with OB. We're dealing with coordinates. That means we have the origin to work with, our central point, which is our taxi stand, to connect where we start and where we're heading, right? The middle ground is the taxi stand, it is the origin. So then, in order to do this, I need to know what OA is, right? You need to know what OA is. OA, we have point A. So OA, even though they didn't ask us for it, you're going to need it. It's -2, 8. We're getting that from the fact that we got the coordinate for A. So the position vector OA is -2, 8 in that column vector form. Now, why do I go for that? Because I am about to use it. So I'm going to represent my AB from A to O. That means I'm going to go inverse to that, which means -2 becomes +2. +8 becomes -8. I'm going the other direction. So if I'm going the other direction, the coordinate, the sign on my components will flip themselves. Now, am I going the opposite direction for OB? No, I'm going in the same OB direction. For those who didn't see, this is OA, but I am going from A to O, inverse. So I have to change the signs of the component. OB, I'm going in the same direction, so it is 4, 2. When you put this together, you get in 6, -6, and that is the vector AB. So to move from A to B, it's going to be 6, -6. All right. Now you notice there was no diagram here, but ideas are flowing. Now let's look at this other question. They asked us for OM. Now, what information do you have about M? It's going to assist you to maximize your effort. Let's go back to the instruction. We were told that M is the midpoint of AB. Oh, it's the middle of AB. Middle means half, but I have AB. So that means if I have AB and the middle of it, so if I have, I'm just saying now, I'm just saying, so this is the line A and this is the line B. They are telling me that M is somewhere here. So it's the middle of that. All right. So then if they want me to find OM, look at this. Let me push this up now. OM, how do I connect O to M? I'm going to use AB and connect O to M because I'm going to move from O to A then I move from A to M. Let's look at my beginning, my ending. So you never had to do that. I'm just going to do one, but I'm showing you ideas. I could have also, let me put a fake O. O is somewhere here. This is O. I was saying O to M, you move from O to A and from A to M. You could have moved from O to B and then B to M. You still get it. So you could go O to B plus B to M. Look at the endpoints. O, M. You still reach O, M. But I'm just going to do one in the interest of time, please. If we do the two of them, is the same answer. So I'm just showing you that there is vectors, you're just walking. Just don't feel, don't feel overburdened. Just walk. How do I move from point A to point B? What is the common ground? So let's put it together. Watch this now. Now, you want to agree that AM is half of AB. Watch this. Let's put together, do I have space to work? I don't know. All right, I'm gonna have to put this on the board. I don't see any space there. I don't see any space. All right, let me just work it here for us. All right, we're talking about OM, and I'm gonna take the route from O to A, and then come down from A to M. All right, AB, I think I remember, it is 6, -6. And I was saying that, look at this, A, B, M is halfway, going in the same direction. So then, watch this now. OA was given as, let's look back quickly, what is OA? OA is -28, and I'm using OA in its right form. -28 is OA. AM is half of AB in that direction, from A to B. So you see now, so this is what I'm saying. Half of AB. Don't overstress enough. Why am I writing out all the steps? Just for you to see it. Half of 6 is 3. Half of -6 is -3. Let's finalize this. -2 plus 3, 1. 8 plus -3, 5. OM is 1, 5. Done, right? OM is 1, 5. We're utilizing the same ideas, same thing, and just walk yourself through as you go. Do not overpressure yourself. Read the instructions, read what they say, and you will come through, right? So OM is 1, 5. You're putting together what they give you, right? And you're working it. All right, let's see the next question. We're almost at the end. All right, let's go. So the vector says, it says, use a vector method, show that AC, all right, so use a vector method, show that AC, use a vector method, show that AC and OB are parallel, right? Show that AC and OB are parallel. Now, do I have AC? Do I have OB? Yes, I have OB. Let's look back what OB is. I have OB. OB is 4, 2. All right, so I'm cool with OB for now. My problem is I don't know what OC is. So I'm going to have to find, I'm going to have to find my AC. Hold on, guys, let me write this a little bit. Now, here it is. 1 second. 1 second, guys. All right, let's go for AC. Now there was a point C that was giving, it's 0, 9. Here it is. This is 0, 9 right there. C is 0, 9. C, that means I know OC. Watch this. I have OC, which is 0, 9. That's OC. Let me take a look at it again. Can't make any mistake with those. All right. So OC is 0, 9. Remember that I have OA. OA is 2. OA is -2, +8. You need to find AC first. AC means that I'm going to move from A to O, plus I'm going to move from O to C. What I'm saying is, in order for me to talk about that AC, I need to find it. So now I'm going to find it. So I'm going to go OA, which is I'm going to go the opposite direction. So AO, so it's going to be +2, -8, going the opposite direction, plus OC, 0, 9, going in the same direction, 2, 1, that is AC. Now let's write them down and take a good look. Now, AC is equal to 2, 1. OB is equal to 4, 2. They say use a vector method to show that AC and OB are parallel. When vectors are parallel, one vector is either a factor or a multiple of the other. In other words, if I look carefully at AC, 2 times AC gives me OB. 2 times it. 2 times 2, 4. 2 times 1, 2. So this statement is the vector method that they're talking. You don't have to work it out to show them. This is it. If I tell them that, hey, 2 times AC is AB, is 2 times AC is OB, that means they're parallel. I never had to say that. I could have turned it the other way. I could have said half of OB gives me AC. Check it out. Half of 4 is 2. Half of 2 is 1. So you're seeing where you can represent your answers diverse ways. Just make sure that you can manipulate one vector and get the other vector. The moment you can do that, then those vectors are classified as parallel. And that's the vector method that they're referring to right there. All right, still going on. Going on, we're in the last piece now, and it is the matrices section. Few more minutes and I'll let you go. All right, so now it says the matrix M is defined as 2p minus 3, 4, 1. Determining the value of P for which the matrix M is singular. Now, what do we know about singular matrix? We know that the determinant of a singular matrix, which is the product of the main diagonal minus the product of the other diagonal, should equal to 0. So in other words then, 2p times 1 minus 4 times -3 is equal to 0. So that's what a singular matrix entails. Taking the determinant and let it equal to 0. 2p plus 12 is equal to 0. We're solving for p. We'll take 12 from both sides. 2p is equal to minus 12. Divide by 2. Then p is equal to -6. Right? So you're seeing that -6 coming up. So if p is -6, then you will see that we will definitely get that. All right. Next one. It says A and B are two 2x2 matrices such that we have those. They want you to calculate 2A plus B. All right. 2A. Let's find out what is 2A first. 2A means that you're going to multiply your A matrix by 2. Right? 2A means 2 times the A matrix. The result of that is 2 times 1, 2, 4, negative 8, 6. So that is 2A. We're supposed to add 2A to B. The B matrix is 5, minus 1, 0, and 3. Adding these corresponding spots, 2 plus 5, 4 plus negative 1, negative 8 plus 0, 6 plus 3. Final response, 7, 3, negative 8, 9. That is 2A plus B. We have that. All right, so that is 2A plus B. All right, so we're going forward. Now they want us to find the determinant of, determining the inverse of B. Inverse. Now the inverse of B is this. Let's write the B matrix here. Now, the inverse is an idea that says that 1 over the determinant of the matrix multiplied by the adjoint of the matrix. So we need the determinant and the adjoint. We merge them and we get that. The determinant of B is going to be 5 times 3 minus 0 times negative 1. Again, concept remains the same. Product of the leading minus the product of the non-leading. 15 minus 0 is 15. So right there, we're looking at the determinant is 15. Now, the adjoint. So let me write adjoint B for us. Adjoint B says switch the elements on the main. So the 3 will go where the 5 is, and the 5 will go where the 3 is. So you switch them and change the sign on the others. So that negative 1 becomes positive. So then this is the adjoint. So the inverse is actually 1 over 15 beside 3, 1, 0, 5. For more simplification, we're going to multiply 1 over 15 by everything, which means a 3 over 15, 1 over 15, 0, and 5 over 15. Right? So we break it down, and there we have that. That is our inverse. Our inverse was already developed from here. That's the idea. They will give you this if they see it. Simplified, here it is. Right? Remember, 0 over 15 is 0, so I didn't bother to write 0 over 15 because it is 0. Now, final question. We're at the end of the paper. Done. Last 2 marks. They're simply asking us.
You can't say anything in the bracket?
Go ahead, ask the question again.
Do you cancel anything in the bracket?
You don't have to. You can if you want, but you don't have to. Is that clear?
Yes, sir.
Yeah, you can if you want, but you don't have to. All right. So it says now, given that 5, -1. You notice we know this matrix. Times this is that. We just found, this is the B matrix that we found the inverse of. So if they want us to solve for X and Y, you don't need to do anything but to take the inverse of the B matrix, which is 1 over the 15. And you could put it in this form if you want, 3105. So that's the inverse. You could put it in that form if you don't want to work with a fraction right now. And put it in front of the 39. And work it out, right? So if you don't, as I said to you, if you don't want to work with the fraction, it's fine. Keep the 1 over 15 outside for now. Do your row by column. So it's going to be 3 times 9 plus 1 times 3. Row by column. I just did row by column. 3 times 9 plus 1 times 3. Now the next row, 0 times 5, 0 times 9 plus 5 times 3. Let's put everything together. There's a 1 over 15 outside. 27 plus 3, that's 30. 0 plus 15 is 15. Now we're going to slide in, right? The 115 over everything. So it's going to be 30 over the 15, then 15 over the 15. Finally, 30 over 15 is 2. 15 over 15 is 1. Now the X is at the top, that means X is 2. Y is at the bottom, Y is 1. Paper is finished. Here it is. We are at the end. So I'm saying to you, this is it. And if you realize that there is nothing there that you never did, then it means that you can get a grade 1 now, because this is a full paper. And if you realize that you did everything already in class, and we have 1 week to go, we will be going through a lot more papers every class and every Sunday until the exam finishes, right? All right, so basically that's where we're gonna stop. And for the rest of you who are with me, I'll see you guys tomorrow for class. Enjoy yourself. See ya.
All right, bye, sir. Take care.
All right.